Good morning, students. Today we are going to have the third lecture of the topic area and perimeter of the figures. And the topic is solving word problems involving composite figures. So this is the today's topic in the topic of the area and perimeter. So concentrate yourself now. In the figure, ABCD is a rectangle. Okay. The ratio of the lengths xy to the length of AB is 1:4. Xy to AB is 1:4. Find the area of the shaded region. Okay, if the length of the AB is 20 and ratio is 1:4, so 5 fours are 20. So it should be 5 because 5 fours are 20. It should be 20, that is AB. So 1:4, it will be 5. Okay. Now the requirement is find the area. Now the question is very simple now. So if this is 5, the height of the rectangle triangle will be equal to this one, that is 16, because this is the height of the triangle. This is also 16. So now the required area is 1/2 into base into height, that is 16. Solve it on the calculator, you will get the answer. Here is a question. The figure below shows a rectangle with 3 identical squares cut out. Find the perimeter of the remaining figure. Okay, if this is 3, this will be 3, this will be 3, this will be 3, this will be 3, 3, 3, 3. Okay, if this is 15 now, 3 will be subtracted, so it will be 12. And if this is 30 total, so this will be cut, so remaining will be 20. Okay, so in total this will be 30. Okay, this will also be 30, and this is 15 total. Okay, now we are going to find the perimeter. So we are starting from here. This is 12 because perimeter is the sum of the outer boundaries, and this portion plus this portion plus this portion makes actually 30. So 30, but these are the also sides, these are also the outer boundaries. So this side is finished now. This side plus 15 plus here we are coming now. So this portion plus this portion plus this portion plus this portion in total makes 30. But here are some vertical walls, 3, 3, and this 3. So 3 times 3. So 3 plus 3 plus 3. So solve it on the calculator, you will get the perimeter. Here is a question. The figure below shows 9 identical squares of side 10 centimeter. Find the total area of the shaded parts. Okay, if this is 10, this is 10. So this is a triangle that is having dimension 10 by 10. Okay. This triangle is passing through the center point. So it will be 5. This will be 10. This triangle will also have base 5 and height 10. So 1, 2. This is the same triangle, 3. This is the same triangle, 4, 5, 6, 7, 8. So in total we are having 8 triangles whose base is, so 8 triangles are there, and area of the triangle is 1/2 into base. So base is 5 and height is 10. So there are 8 triangles in total, and one is different triangle that is having base 10 and height also 10. So solve it on the calculator, you will get the answer. Statement of the question is, each of the following figures is made up of the identical rectangles. Find the area of each small rectangle in each figure. Okay, So if this is 1 unit, so this is 1 unit, 1 unit, 1 unit. So in total, this will be 3 units. This is the width of the full figure now. And if this is the length of the smaller rectangle, this will also be 3 units. Okay. Perimeter of the figure is given. So now 3 units plus 4 units. So 3 plus 4 plus 3, because this total will be 3 and this total will be 4. So 3 plus 4 plus 3 plus 4 units will make in total 56 centimeters. Solve it. 7 plus 7, 14 units is equal to 56 centimeter, and 1 unit will be equal to 14. 56 divided by 14 will be 4 centimeters. Okay, so 1 unit is 4 centimeters. So if this is 4, this will be 12, and this will also be 12. So the dimension of the, now the requirement is find the area of each small rectangle. So each small rectangle's dimensions are 12 into 4. So 12 into 4 equal to 48. This is the area of one small rectangle. The figure below shows is made up of the 3 identical squares. So these are squares and 3 identical rectangles. So here, here, and here are rectangles. Find the area of the figure. Okay, if we suppose the width of the rectangle is 1 unit, so this 1 plus 1 will make 2 units. So this is 2 units. This will be also 2. This will be 1. This will be 2. This will be also 2, because this is the dimension of the square. So this is 2. This is also 2. This is 2. This is 2. This will be 2. This will be 2. This will be 1. And this will be 2. Okay. Now the requirement is find the area of the figure. So area of the figure is required. So 2 into 2 plus 1, 3 plus 2, 5, 7, 9. So 2 into 9, 2 into 9 units, square units, represents 132. Actually, the perimeter of the figure is given. So perimeter of the figure is this. So 2 plus this full side is 9 plus 2 plus 9 units will represent the perimeter, that is 132. So 2 plus 9, 11 plus 11, 22 units will represent 132. And from here, 1 unit will represent 132 over 22. So 2 ones are 2 ones are, 2 6 are 2 6 are, and 11 6 are. So 1 unit represents 6 centimeter. Okay, find the area now. So this will be easy now. So area is equal to, if 1 unit is representing 6, so 2 unit will represent 12. So 12, and this is total 9 units. So 9 into 6 will be 54. Solve it on the calculator, you will get the answer. Here is another question. The statement of the question is the figure below is made up of the 9 identical squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9 squares. Uh, the total area of the 9 square is 225. Okay. So if this is x, this is x, so area of the 9 squares will be is 225. So 225 over 9. 9 twos are 18 and 9 fives are 45. So 25 square units, square centimeter, is the area of one square, and each side will have 5 side. So 5, 5, 5, 5, 5, and 5, and this side will also be 5. So 1, 2, 3, 4, 5, 6, 7. 7 fives are 35. So this is the length, that is 35. Okay, this is the side 20. So in total, this total side will be 20. So now the requirement is find the perimeter. So this side plus this side will make 35. So this upper portion is done. This is 20. Okay, this total is done. This is left still. Okay, this total length is 35. This will be left, and this total is 20, in which this portion plus this portion will make total 20. So done. Solve it on the calculator, you will get the answer. Here is another important question. The figure below shows two different squares. The length of the side of the bigger square is 18. So this is 18 and this will be also 18. Because these are two squares, so this will be right angle. And this is a square, so suppose if we let it x, this will be also x. So in this triangle we are going to apply the Pythagoras theorem, that is equal to hypotenuse square is equal to perpendicular square plus base square. Hypotenuse is 18, so 18 square will be equal to x square plus x square will be equal to 2x square. From here you will find the value of x. The x will be the dimensions of the smaller square, and we have the dimensions of the bigger square already. So the required area will be equal to 18 square. This is the area of the bigger square plus this triangle. So when you have find it out the x, so this will be a triangle that is attached to the bigger square. So 1 by 2 into x into x. So whatever the value you have find it out in this part, you will put over here, and that will give you the total area of the figure. Here is another important question. The figure below shows a semicircle of diameter 28. So this is the diameter of the semicircle. O is the center of the semicircle. Find the total area of the shaded part. So this is 28. So radius of the circle will be 14. So this is 14. This will also be 14. Okay. So the area of the shaded part is required. The formula will be semicircle. So pi r square divided by 2 minus this triangle will be subtracted, 1 by 2 into base into height. So values will be put into the formula. Pi is 22 by 7, radius is 14, so r is 14. Base and heights are 14 into 14, so 14 into 14. So solve it on the calculator, you will get the answer. And other question is here, the figure below shows a square. So here is a square, a quarter circle, this is quarter circle, a semicircle, and a right angle isosceles triangle. Okay, this is isosceles triangle. The radius of the semicircle is 5. So if the radius is 5, so this total side will be 10. Because this is an isosceles triangle, so this will also be 10. And we are coming actually in the square. So if this side is 10, so this will be also 10 and this will be also 10. Okay, now the requirement is find the total area of the shaded part. Okay, shaded parts area can be find out by required area will be equal to this square, that is 10 square, minus this quarter. So this is the quarter, that is pi. R square will be 100 over 4. So this is the quarter. So this is this shaded area plus this triangle. So plus 1 by 2 into 10 into 10. Solve it on the calculator. You will get the answer. Here is another question. The figure below is formed by a square and a semicircle. So here is a square and a semicircle. Here is semicircle. The total area of the shaded part is 98. Find the perimeter of the figure. Okay, because this is a square and these are actually diagonals, so this side will be equal to this and this will be equal to this. So suppose if this is x, so here will be diagonals cut each other at 90 degree. So the triangle's area is 1 by 2 into base into height, and there are actually two triangles. So in total, these are actually making shaded part. So shaded part is 98. So this is cut. X square is equal to 98. So from here you will find the value of x. And when x is pointed out, you will apply the Pythagoras theorem. That is hypotenuse square is equal to perpendicular square plus base square. So this side plus this side, so x square plus x square. So the value of the x will be placed here. You will find the hypotenuse as well. So now the requirement is find the perimeter of the figure. So you will be able to find the perimeter of the figure now, because okay, this side is find out. So this will be the same, this will be the same, this will be the same. And from here, whatever the side this is, you will make it half. That will be the radius of the semicircle. Apply it into the formula of the semicircle. You will find the curved surface of the semicircle. So this side plus this side plus this side plus this side will make into. Here is another question. The figure below shows a square ABCD. So this is a square and two identical semicircles. So here is a semicircle and here is a semicircle. The area of the square is 100. So if the area of the square is 100, so this side will be 10, this will be 10. Okay, find the total area of the shaded parts. Okay, and in the square, these are the diagonals. So this side and this side will be equal. Okay, suppose this is x, and diagonals cut each other at 90 degree. So first we will apply the Pythagoras theorem. So hypotenuse square is equal to perpendicular square plus base square. Hypotenuse is 10, that is 100. Perpendicular and base are each of x, so x square plus x square. So 2x square will be equal to 100. From here find the value of x. So this will be the x. Okay, now shaded part is required. So we are going into this portion. So this is a semicircle, pi r square. Radius is definitely will be x. So whatever the value of the x that you have find out in this portion, put over here, pi r square over 2, because this is a semicircle, from which subtract this triangle, minus 1 by 2 into base into height, that is x into x. So this portion will give the shaded portion, this and this. On the other side, the same thing is there. So just multiply. So multiply the full portion with 2. You will get the answer. That is the required answer.